Hello friends, welcome to Mathematician Impossible again, and today we are going to learn about congruence of triangles. What means congruent? Do you know them? Congruent means when two figures are similar and have equal length between them is called a congruent figure. For example, let's get a congruence of triangles. I'll just give examples. Take a line with 5 centimeters and another line of 5 centimeters, and congruence means that these two triangles are congruent to each other. That means they are similar, right? They are not bent or curved, something other else, and they are similar, and even they are equal in length. So, which means that these two figures are congruent to each other, which means that. So now let's take a circle with the radius of 1 and another circle with radius of 2, and these are not similar, as radius 2 means it's larger than a figure with radius 1, a triangle, so it means they are not congruent. A circle is congruent when the radius of it are equal. So we know what's congruency. Now let's come to congruency of triangles. Okay, I will change the color of my pen. So, congruence of triangles. Okay, let's start with it. Two triangles are said to be congruent if every part, that side, angle, median, altitude, etc. of one congruent to every corresponding part of the other. That means like this. If these two triangles, let's take it. Actually the pen ink is out. Okay, so congruence tells us that the medians and these medians and the sides, all the sides, and the angles, these angles, and the altitude, and what are the else? Perpendicular bisector, all are equal. When all are equal in a triangle, I'm running out of ink. Okay, wait a minute, let me change the okay, in a triangle, when all these are equal, we then only say that the two triangles are congruent to each other. But soon afterwards, mathematicians got idea of simplifying the criteria of finding the congruence of triangles, and now they splitted the congruence into 5 parts. Yeah, it's 5 or 6 something, I'll tell you later. The first is to find two triangles if they're congruent. First is SSS congruence criterion, and SAS congruence criterion, and ASA congruence criteria, and then will be I forgot it. The next will be RHS, the next will be RHS, and RHS means right hand side, right hand side congruency. And let's define it. SSS means side, and side. SAS means side, angle and side. ASA means angle, side and angle. And RHS means right hand. Yeah, it's side. It's right hand side, okay? And what do you mean by them? What do you mean by them? They mean this is SSS side side side, this SAS side angle side, ASA angle side angle, RHS right hand side. And what do you mean by them? SSS means when the lengths of each side of a triangle are equal to the corresponding parts of the other triangle are equal. So when this side is equal to this side is equal to this side equals to this, then it's said to be in a congruent rule of SSS. If this is applicable for these two triangles, then it is said to be, the two triangles are said to be congruent. And similarly, S, a side, an angle and a side. That means the side, this is equal and these two are equal and the corresponding angle is equal. So side, a side and angle and a side, when they are equal, then it is said to be congruent by SSS congruency criteria. And then ASA means an angle and a side. An angle and a side are, when they are equal, it is said to be congruent. These two triangles are said to be congruent by ASA criteria. And RHS means they are only applicable for right triangles when like this. Let me change the color. Okay, wait. So when the hypotenuse are equal to the next hypotenuse and the angle, that's the right angle, they are always equal, and the height, and actually I wrote it wrongly. This is actually not right hand side, this is actually right height and side. This is right height and side. Wait, right height and side, right? So the right will be this and height will be this. You can also keep it as hypotenuse, right hypotenuse and a side. So right hypotenuse, these two hypotenuses are equal, and the side, this side, if they are equal, then it means the two right angle triangles are equal, are congruent to each other. And we are done with the congruency conditions. Now let us see some examples on them. Wait, let me draw a figure. Okay, I'm ready with the figure. That's this is square A, B, C, D, and before that I'm gonna introduce you to the symbol of congruency. I forgot about it. The symbol of congruency is like this. This is a symbol of congruency. We tell it like, for example, take this ABC and PQR. We tell that ABC is congruent to PQR, like that. We define it like that. Okay, now let's build up with a problem. So wait a minute. Okay, so ABCD is a square and AD measures A centimeters. So at R is ACD and BDA congruent to each other, and if yes, verify it. How can we do it? Okay, now AC equals CD, right? Because AC equals CD because it's a square. Let's name it as B, and even this B. So these two are equal, and even AB is B and even BD is B. Okay, so we are left with, we are done with 2s, because AC is a side, AB is a side. We are done with s, and CD is a side, BD is a side with equal length. So we are done with another s, and now we are gonna test with any other side or angle. So AD is the diagonal of the square. So this is a common line. So it should be equal. It should be equal for both the triangle. So it will be even a S. So now we can say that ABD triangle ABD is congruent to triangle ACD. Yeah, we are done with it. We are done with the example. It suggests that I forgot to tell you another thing. ABD is congruent to triangle ACD by SSS congruence criterion, and this should be mentioned all the time when you write the congruency rule over it. And I hope that you have understood today's lesson. Let's see in another video. Until then, bye bye.